computer and being able to fine tune it from the computer. So it's gone from just, a shot in the dark to really, extremely significant modification, exactly in the site that they want. One thing that's going to help that is in the last year, we just solved the first part of the genetic code of corn. We got the first draft of that done. And so now the real push is to go to functionality of those genes. And so biotechnology is going to move forward at a faster and faster rate now, because now we know the code and we can find what areas are of interest to us. We know exactly where we're inserting the genes. It's going to accelerate our biotechnology quite a bit. And this is about the adoption of GMO corn in the U.S. and Iowa. Right now, the legal limit is about 80%, so you can see that everybody is just about up against what's legally allowed. And that's the 80% limit is there because it's to prevent insect resistant. You've got to have some non-GMO plants out there so that you're not developing insect resistance. They're exposed to the old technology, and some of them survive that and then interbreed with the ones that might be trying to develop, adapt to the new varieties, and it limits the insect's ability to adapt to the new technology. But it's also coming that there'll be different modes of action in corn. We won't have to plant a refuge, because there'll be about 3 modes of action that will kill that insect in every plant. It's a totally natural biology that kills specific insects. It's not a wide-ranging chemical or anything in there. It's a Bt gene that the insects can't digest that protein, and so they die. But it's specific to that insect, so it's been tested. It's safe. But we'll have lots of modes of action in a single corn plant, so the ability of an insect to become resistant is much less. The new biotech traits that are coming that mean a lot is drought resistance. Drought traits is going to expand the corn belt into drier areas and prevent yield loss. Stalk rot resistance, so the plants will stand better. Yield enhancements are going to be fantastic. Some of our seed providers are saying in the next 15, 20 years they're going to double the corn yields, average corn yields in the United States. And they've put that down in writing, and that's their goal. And with the new biotechnology and the new marker system of introducing those traits, there's no doubt that they can do that. It says progress on sequencing the corn genome code is about 70%. It's done. It's twice as complicated as a human genome. It's hard to imagine that, but it is. They're talking about ongoing yield increases, and that's added more acres in the U.S. By 2014, we're expected to increase corn production, an increase to 267 million metric tons to 386 million metric tons by 2014. And eventually, average yields could average, 18.8 metric tons per hectare. So lots of things coming. This is just kind of a chart that shows that projection. Talking about Iowa's crop right now, I see it says the condition is 65% good to excellent. Actually, it dropped to, I believe, 61% just this week. There have been some, but we're almost exactly where we were a year ago. I think we're about the same level on good to excellent. So the forecast is for 312 million metric ton crop, which would be the second largest corn crop in the United States history, so we're well on track for raising a big corn crop. The USDA did a lot of extra sampling because of flooding in Iowa and Illinois to try to make sure that they weren't overlooking some of those damaged areas, and they feel very confident that the corn crop's out there. There's some discussion about early frost. we don't need an early frost because a lot of the crops are planted late, but maybe global warming will help us out this time. So we'll know when the grain's in the bin. This talks about U.S. Supply and demand. The thing to notice here is that we still, you know, in spite of the increasing usage and demand on corn, we still have a substantial carryover. And that's the thing I want you to bring forward from this. This talks about the usage of corn in the United States, the 2007 crop. You know, we got, you can see the 142 million metric tons to feed livestock, 56.9 million metric tons went to ethanol, 18.1 million metric tons are processed into the starch, corn oil, and sweeteners, and 62.2 million metric tons went to exports, and 88.3 million metric tons were processed into corn flour, grits, and cornmeal, and beverage alcohol. The main purpose of this slide is to show out to 2015 an estimate of yields and uses for the crops. And the thing that I want to point out here is the surplus. There's always a surplus. You know, there's not going to be a shortage of corn. There's going to be a shortage of cheap corn. But I think we're going to be able, with the yield increases and the technologies coming, we're going to be able to carry forward a surplus. And so that's a good thing that comes out of this slide. This talks about the ethanol industry, how many plants that we have currently operating. The rate of expansion is slowing. We're at about 9 billion gallons of ethanol now, and really that's kind of saturated the easy markets. Or we have trouble transporting ethanol. We can't put it through a pipeline, and so it all has to go by rail or truck. And so when you get to the outlying areas away from the Midwest, it becomes very expensive and energy consuming to transport that ethanol. So we've filled the kind of easy markets around the Midwest, and now we're moving into areas where it's very expensive to transport it in and blend it. So as that goes forward, those are going to be tougher and tougher areas to get into, and so there's less likely that the ethanol industry is going to expand to try to go into those areas because of the cost factor. You know, there's very low margin to go into those very outlying areas. So the rate of expansion is slowing. You know, the rush is off now, so economics always come into play and start to be the ultimate decision about what plants are being built. This talks about the boom mentality is fading. Some of the processing was affected by the floods, not that large amount, but a few plants were flooded. But new technology will change the production methods and improve the co-products, the DDGs that a lot of you folks are using. I appreciate that. It's a big help to the ethanol industry to be able to move those into the food supply. There's going to be more varied feedstocks that come out of ethanol plants with fractionation process. It's going to take the germ out of the kernel to begin with and take the oil out. We'll end up with a different kind of protein in the end. That won't happen at all the plants, but there's going to be a wide variety of feedstocks that come out of these ethanol plants. We're very new industry. As it matures, there's going to be a variety of feedstocks that are going to be produced. We expect corn use for ethanol to grow, but it'll be a manageable rate that we can meet with our increased production. DDGs, a lot of you folks know about DDGs. The Grains Council has done a great job. Adele is going to help you anytime you need advice with DDGs. We appreciate everybody that's been willing to step forward and use this product. The thing about the ethanol plants, the corn that goes into those ethanol plants, we take the starch out, and that leaves a third of it for high